Hello, today we are going to take a look at calculating the average rate of change of a function. First, I'd like to go over what this looks like at its foundational level of why we get the formula that we do, and then we'll look at a few examples of how to use this and put it into practice. First, we want to take a look at this function f of x over this interval from a to b. A and b are our x coordinates, so the y coordinates of these points, we are going to use this as f of a and f of b. So if we were to find our average rate of change, which we can represent with m for our slope, it's just like we've been calculating slopes since middle school. It's our rise over run, our change in y divided by our change in x, and so we are going to do y2 minus y1, so f of b minus f of a, because our point b, f of b is x2, y2. Our a, f of a is x1, y1, divided by b minus a. All right, great. We know how to find slope, but we want something that's more specific and in terms of fewer variables. So what we're going to do is, instead of using point A, we are going to call point A x. That means that f of a is just f of x. So we're going to replace a with x. Now, to find our average rate of change, the slope of this secant line, we need our second point. We're not going to call the point B. We are going to look at this distance between our two x values is delta x. It's a little triangle for the Greek letter. Delta represents the change in x. So this point B is going to be x plus delta x. Think about it this way. If we said x was 1 and this point at B was at 3, we'd know delta x would be 2. We could say that point B was at 3, or we could say it was at 1 plus 2, which is x plus delta x. Now, those are just example numbers for now. So we start at whatever our x value is, add delta x, and that is our new x coordinate here. So instead of b, we're going to substitute in x plus delta x. We can simplify our denominator because x minus x is 0. So our average rate of change, the slope of this secant line, can be represented by this equation, f of x plus delta x minus f of x divided by delta x. So it's our change in y divided by our change in x, represented by delta x. Let's take a look at where we would use this. And we are going to use this formula with a little something extra later on when we look at instantaneous rate of change. We are going to take a look at using these functions. We have to start with a function, finding a general equation for the average rate of change and using it to find the average rate of change over a given interval or intervals. So what we're going to do is start out with our formula. We've got our f of x plus delta x. Let's do one that there's a little more contrast. So minus f of x divided by something that we can't see here. We can do this in yellow, divided by delta x. Our function is x squared minus x plus 1. For this function, make sure when you're substituting in x plus delta x, you are doing it for every one of the places where x is in this function. So we have the quantity x plus delta x squared minus, in parentheses, x plus delta x. Just like with many other things we're doing, one of the biggest common mistakes is just some little sign errors. And don't forget that plus 1. You're including the entire function. It's f of x plus delta x. Just because the 1 doesn't have a variable doesn't mean we leave it behind. Then we have to subtract f of x. And we know that this is f of x. I know it says y, but typically we will say f of x. It's the entire function that we have to use. So we have x squared minus x plus 1. All of that is inside those parentheses. And then we still have divided by delta x, which we have to write in every step, even though it feels a little silly at times because, we don't do anything with it until later on. For accuracy and completeness, we need to include it in every step. So let's expand. X plus delta x squared. Remember, we've worked with the binomial theorem recently, so we know that the expansion of this is not just x squared plus delta x squared. It's x squared plus 2x delta x plus delta x squared. We distribute this negative sign here, so we have minus x minus delta x. Still that same old plus 1. Then we come over here, have to distribute this negative, so we change all of our signs in our f of x. So we have minus x squared plus x minus 1. Still all divided by delta x. Now, we want to start combining like terms whenever we can. Sometimes you will have to do an additional step, but in this case, we do not. So we take a look. We have x squared minus x squared, some common factor, not common factors, some like terms. They add to 0 because they are opposites. Negative x plus 1 minus 1. So our function now is 2x delta x plus delta x squared minus delta x, all divided by delta x. If we have done this correctly, every single term in our numerator is going to have a delta x in it. So we can factor out this delta x in the denominator with one of these here for the one that's squared. And so we have 2x plus delta x. And don't forget, this here is a spot where people make some errors. Don't forget that we are factoring this out and not just crossing it out. What do we do with factoring? It's dividing. So we're doing negative delta x divided by delta x. So that is going to be a negative 1. A lot of mistakes happen because people just think, yep, we cross it off and it just disappears. So if we're aware of that happening, it's like we know that there's a break in the sidewalk, we can step over it and are less likely to trip. So we have this function, this m equals m as our slope of our secant line. Our average rate of change of this function is 2x plus delta x minus 1. And this will give us, if we have 2 points, the average rate of change of the function over that interval. How this works, we take a look at our interval, and we need to set x and set delta x. X, I always like using our lowest value here. And then our delta x, you do your greater value, subtract your lesser value, so 3 minus 0, our delta x is 3. Then we take these values, substitute in to our function, and that will give us our average rate of change over this interval. So x is 0, delta x is 3, 2 times 0 is 0, plus 3 is 3, minus 1 is 2. So our average rate of change over the given interval is going to be 2. If we had a different set of points for this same function, we could do the same thing, just find your x, find your delta x, and substitute in. Let's take a look at another example. Now, this one is also a quadratic trinomial. All the examples we're going to do today are going to be quadratic. There might be some that are cubic or something else later on. So we do f of x plus delta x minus f of x, all divided by delta x. Our f of x plus delta x, in every location we substitute in an x plus delta x for x. Well, I guess I don't need to put that in parentheses because it's a positive x plus delta x, because this is coming from here. And then plus 2, don't forget that. When we're subtracting our original function, put it all in parentheses, because it's all going to get subtracted. All right, our first step here, we need to expand any x plus delta x squareds or cubed or anything else. So that's x squared plus 2x delta x plus delta x squared. And then we have plus x plus delta x plus 2. Distribute the negative. So we're changing all our signs in our original function. So we have minus 2x squared minus x minus 2. It's all divided by delta x. What we can do here is start combining some like terms. 2 minus 2, 0. Same thing with x minus x. Then, next step, we can distribute the 2 over here. So we have 2x squared plus 4x delta x plus 2 delta x squared. And then we still have that plus delta x and the minus 2x squared. And all divided by delta x. 2x squared minus 2x squared is 0. And then if we've done things correctly, we should have a delta x in every term in the numerator. So we can factor this out. So this becomes 1. Remember, delta x divided by delta x is 1. Factor out a delta x here and here. So our equation for our average rate of change is 4x plus 2 delta x plus 1. In this case, we're going to look at this. We've got our x value is 0 because I like using the lower value as our x value, and then delta x is 1/2 minus 0, which is 1/2. We'll do an example in a second that it's not just the two endpoints because it doesn't always include 0. We substitute 0 in for x, and then 1/2 in for delta x, and evaluate. So our average rate of change over the interval 0 to 1/2 is going to be 2. Say instead our interval was -1 to 4. Or by 4 I mean, let's do 3. What we would do here, we'd still set x equal to -1. Now we're using the same function, so we can use our same function for our average rate of change over an interval. X is equal to -1 because I like using the lower value. You could do the upper value, but then your delta x would be negative, and I like just trying to keep the delta x positive when possible. So our delta x in this case is going to be 4 because it's going to be our greater endpoint, so 3 minus that -1. So we end up with 3 plus 1, which is 4. So we substitute it into our formula. So 4 times -1 plus 2 times 4 plus 1. So we have -4 plus 8 plus 1. So 9 minus 4 is 5. And no matter what 2 points we had, we could always find the average rate of change over that interval by using this formula with our f of x plus delta x minus f of x divided by delta x, substituting in, evaluating, simplifying, and then use your x and delta x to evaluate your average rate of change, your slope of your secant line. All right, thank you for watching.